Capacitance. 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 A conductor's ability to store energy in the form of electrically separated charges is measured by the capacitance of a conductor. A capacitor is a device that is used to store electrically charged potential energy. An example of a capacitor would be a typical keyboard. A parallel plate capacitor is often found in older keyboards, but not in the high-tech ones in today's world. In this keyboard, you have a movable metal plate, which is right under the key, and then you have a fixed metal plate, which is at the bottom. A parallel plate capacitor design is the design that is most typically used throughout physics. A capacitor is energized or charged by connecting the plates to the two terminals of battery or other source of potential difference, and then the energy stored on the capacitor can be reclaimed later on and used for a different activity. Also, the equation for this parallel plate capacitor in a vacuum is C equals EO times A over D, which means capacitance is equal to permittivity of a vacuum times the area of one of the plates divided by the distance between those two plates. Capacitance is defined as the ratio of magnitude of net charges present on each plate to the potential difference that is created by the separate charges. This equation is also known as C equals Q over the change in V, or magnitude of charge on each plate divided by the potential difference. The larger the amount of potential difference, also known to be voltage, between the two plates, the larger the charge on the plates will be. For any given potential difference, the charge on the plate is proportional to the area of plates and inversely proportional to the separation of plates. A chargeless capacitor can hold electrical potential energy because a charged capacitor requires work to be able to move charges through a circuit and to the opposite side of that capacitor. Also, no work is required to transfer a small amount of charge from one plate to another, only when both plates are at the same electrical potential, like in an instance where a capacitor is initially uncharged. Once a charge is transferred, the electric potential energy increases as a small potential difference appears between the two plates of the capacitor.